All right, so we're going to start Unit 1 about exponents, and today's lesson 1.1 is called Product, Power, and Quotient Rules of Exponents. So we're going to break each one down into the rules. First one is called the product rule. And you should know that product is the answer to multiplying something. So this is when you're multiplying exponents. Before I tell you what you do with the powers, let's start with a very simple example that says x to the third power, or you might say x cubed, times, that's what that dot means, x to the fifth power. There's no name other than x to the fifth power. Okay, so I'm going to write this out. I'm going to expand it as much as possible. So x to the third power means some number x times itself. So x to the third power looks like that. Then times x to the fifth power would be x times x times x times x times x. 5 of them. Okay, so now let's say, okay, this is all multiplication. Let's condense it into a single exponent. How many x's are getting multiplied together? Well, if there's 3 here times another 5, that means really what I'm doing is getting x to the 8th power. And what would I do with 3 and 5 to get 8? I would add. So you need to remember that when you're multiplying exponents, you're actually adding the powers, which are the little numbers raised up, as long as they have the same base. The base is the big part. In this case, it would be the x's. Okay, so let's try some harder examples with multiplying. Number 1, we got 3x to the fifth. There's nothing in between here, so this is times 2x cubed y cubed. Okay, the parentheses aren't really doing anything here. They're just separating this term or this monomial and this monomial. So I'm going to take them away. 3x to the fifth times 2x cubed y cubed. Everything is getting multiplied together. So what you want to do is take the coefficients or the numbers in front times each other. So 3 times 2 would be 6. And then we're going to use our product rule. We've got exponents with x. So there's x to the fifth times x to the third. Think about those written out. It's exactly like what we already did. So you would actually add the 5 plus the 3 would be x to the 8th. And then I have times y cubed. So there's no plus or minuses in this. This is all one monomial is what it's called, because it's just all one term where everything is 6 times something to the 8th power times something cubed. All right, number 2, very similar. We've got a negative here in front of the 4 you got to watch out for. Again, there's multiplication between my terms. These parentheses are doing nothing. So I'm going to take them away. I've got negative 4. X is really to the first power because there's no power after it. Only the y is cubed. Times 5. This is another x to the first power, y to the fifth. Okay, so you would want to multiply your coefficients or your numbers in front. Negative 4 times 5 would be negative 20. We have an x times an x, or 1 plus 1 would be x squared. Y cubed times y to the fifth, 3 plus 5 would be y to the 8th. That 3 and 5 keeps showing up. So your final answer would be negative 20 times something squared times something to the 8th power. All right, if you feel good, you can pause and try 3 and 4. All right, number 3, you have a coefficient really of a 1 here. I'm not going to write it out. I'm going to get to where I just know, hey, I'm multiplying. 10 times 1 is 10. I have x cubed times x squared, so I would add 3 plus 2 would be x to the fifth, and then I have a y cubed. So that would be your answer. Number 4 would be 3 times negative 14, which is negative 42. And then I have x cubed times x squared, so 3 plus 2 be x to the fifth again, and then 4 plus 5 would be y to the 9th is what you should have gotten. All right, next section is talking about the power rule. Power rule is when you're raising a power to another power. I'll show you in an example before I tell you what to put in the blank here. So we have x being squared. This is happening and then it's raised to the fourth power. So that's what I mean by taking something that's already an exponent with a power to another power. So if I expand this out, I'm going to write x squared times itself 4 times. So there's 1, 2, 3, 4. And then I'm going to expand even more by saying x squared is really x times 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 x. So every x squared I wrote x times x. How many are there? 2, 4, 6, 8. So this would really equal x to the 8th power. So what do we do with the 2 and the 4 to get 8? We multiply. So when you have a power raised to another power, you're going to multiply those powers, keep the base. All right, so number 5, let's get to a trickier one. We've got this whole inside part being squared. So that means this times itself, I'm going to write it out. So it's 3x to the 4th y cubed times another 3x to the 4th y cubed. So it looks just like the problems we had above. We would want to take our 3 times 3, which is 9, and then since we are multiplying here, we're going to do our product rule and add the power. So x to the 4th times x to the 4th would be 4 plus 4, which is x to the 8th. And then we would have 3 plus 3, which is y to the 6th. Okay, but I'm not going to write them out like this every time. The shortcut that I use, it's almost like a distributed property where everything gets its power on the outside. You have to take this leading coefficient of 3 to this power. So 3 squared is 9. And then take our powers and multiply. 4 times 2 would be 8. 3 times 2 would be 6. So that's what I'm going to do on the next one. Okay, so number 6, it would be this inside part times itself 5 times. But instead, I'm going to take negative 3 to the 5th power. I'm going to write that over here. Okay, I'm going to teach you how to use your calculator. Make sure you turn it on, which is down here at the bottom. You have to have parentheses anytime you're doing an exponent, and I'll get into that a little more later. So you put parentheses, negatives here, 3, close parentheses. This little up arrow is your exponent. So hit that, and then it'll come up with a little box and put in the 5. Hit enter, and that's a negative 243. Makes sense that I'm getting a negative because I'm taking a negative times itself an odd number of times. So remember, every negative times negative is positive. Well, if you have an odd power, it's going to be negative in the end. Okay, and then my power rule says to multiply. 2 times 5 would be x to the 10th. 4 times 5 would be y to the 20th. Okay, so here's where the parentheses are important. We've got an even power on the outside, and we're taking a negative 4 raised to the 4th power. Okay, I'm going to show you this example of why you need parentheses. So I've got negative 4 to the 4th power is 256. If I don't do parentheses, I get a negative, 2 different answers. And it's not that your calculator is stupid, it's you have to put it in right. So the difference between the two is your calculator is doing order of operations. This second example, it's going to do 4 to the 4th power first, get 256, and then times the negative, because PEMDAS tells us to do exponent before multiplication. Versus this top one, which is the right one, says, hey, I want you to do negative 4 times itself 4 times. And that gets you a positive when you have an even power. So that would be 256. And then 2 times 4 would be 8. And then this y is to the first power. 1 times 4 is 4. So why don't you go ahead and pause and for sure try number 8. You should have done negative 3 to the 3rd power. It's an odd power, so it should be a negative. 3 times 3 is 9, times 3 is 27. This x is to the 1st power, so it'd be x cubed y to the 15th. Okay, and last rule, dividing quotient or dividing exponents, that's called the quotient rule. So think dividing, you should know the answer to that kind of problem is called the quotient. An example, let's expand again. If I had x to the 6th power, that would be x times itself, 6 times, divided by x to the 4th. X is a number, and it's a number for every x you see, and it's that same number. So let's say x is 10. If this was 10 and this was 10, what's 10 divided by 10? 1. Any number divided by itself is 1. So that would make 1, 1, 1, 1. So these all cancel out to leave you with 1. What's left? X times x, which is really x squared. So what do we do with 6 and 4 to get 2? We subtract. So when you're dividing exponents, you're going to subtract the powers. Kind of goes together in a nice pattern, right? We were multiplying exponents, we add the powers. When we divide exponents, we subtract the powers. Okay, so number 9, you want to divide your coefficients first, which are these numbers in front. So you do 25 divided by, this is division, 25 divided by 25 is 1. Okay, x to the 7th over x squared. So think about x written out times itself 7 times over x times itself 2 times. Cancel out all the pairs, but you could only cancel 2. There'd be 5 left, or 7 minus 2 would be x to the 5th. And then this is y squared over a y to the 1st. So 2 minus 1 would be y to the 1st, which is y. I don't need this 1 in front, so I'm going to take that off and just have x to the 5th times y. All right, number 10. We've got 4 being divided by 8. Now be careful here. It's a little number over a big number. It's not 8 divided by 4. It's 4 divided by 8. These are two different things. 8 divided by 4 is 2. 4/8 reduces down to a half. So what I like to do is think, okay, I'm really just simplifying that fraction and setting up this division bar because something special is going to happen here. See how the x squared is on top and x to the 6 is on bottom? There's a bigger power on the bottom of the fraction. So look at this. If I had x squared, that'd be x times x and then x to the 6th. X is a number, so let's say it's still 10s. 10 divided by 10 would cancel, cancel. Since they're canceling to make 1, 1 would have to go on the top. And look how many x's are left over on the bottom, 4. So this is really 1 over x to the 4th. Well, I've already got a 1 here in the top. So what I like to do is just think, subtract them, and wherever the bigger number is, that's where your answer goes. So since it's 6 minus 2 is 4, but the bigger number was on the bottom, I'll have x to the 4th in the denominator. And then y squared divided by y squared, they would each cancel, right? 2 minus 2 is 0, so they're gone. So you get 1 over 2x to the 4th. All right, number 11, divide 12 by 8. That doesn't divide evenly, so it's going to stay a fraction, but it needs to be simplified or reduced. What can 12/8 both be divided by, or what can 12 and 8 both be divided by? 4. So 12 divided by 4 would be 3. 8 divided by 4 would be 2. So I get 12/8 is the same as 3 halves. And then I'm going to do my rule. 6 minus 4 would be x squared. The bigger number's on top, so that's where the x squared goes. Okay, this is a y to the 1st. I'm going to do 5 minus 1. The bigger number's on the bottom, so it'd be a y to the 4th on the bottom. Okay, go ahead and pause and try number 12. All right, 9 over 27, that's the same thing as 1/3, because they can both divide by 9. Okay, 7 and 8, let's see, 8 minus 7 is 1, but the bigger number's on the bottom, so I'd have x to the 1st on the bottom. And then I have 5 and 7. 7 minus 5 would be 2, and that would go on the bottom. I don't need that 1, so I got 1 over 3xy squared. And that's it for the notes. So you have a homework assignment on Delta Math over 1.4.